Now we are going to learn how to derive the expression for excess pressure inside the air bubble. Already in the previous video, in the previous topic, already we have seen that excess pressure that is acting in the concave surface. Are you clear? I will explain how the excess pressure it is acting within the air bubble. Here, this is the complete structure of the air bubble within the liquid. Whenever you blow the air through the liquid, air bubbles will be formed. So the air bubble is usually it is surrounded by liquid. Here, for our derivation purpose, the air bubble that is split into two hemispheres. So here we have taken one of the hemispheres. So before going to derive, we have to understand how many number of forces are acting in the air bubble. Are you clear? Here there is a pressure. That pressure can be called as P1. The pressure which is acting from inside, it is called as P1. There is another pressure that is acting towards downward direction, that is acting on the surface. So one pressure is acting from inside, another pressure is acting from outside. And the most important thing is always the excess pressure. Excess pressure means difference between these two pressure is called excess pressure. That excess pressure will be acting all only in the concave surface. Therefore, del P, what is del P? Del P means excess pressure that is acting only on the concave surface. That you should not forget. So it shows that P1 is dominating and P2 is less. So excess pressure can be written as del P can be written as, since del P is acting in this direction and P1 must be greater than P2. Therefore, P1 minus P2, that difference that gives you excess pressure. So both P1 and del P both are acting in the same direction and P2 is acting on the surface that is from outside. So here, this expression, excess pressure expression to be derived, that is our aim. And one more thing is, here let us imagine a molecule. That molecule, it is pulled by two forces here due to surface tension. If it is extended for the molecule which are present in the rim, so these are all the molecules which are present on the circumference of the rim of the air bubble. Okay, these are all the molecules which are present located on the rim of the air bubble. So on each molecule, what will happen? The force due to surface tension, they are acting in the downward direction, because if the lines are extended for other molecules also, the tangential force, they are acting on either side. If the same lines are extended here, so these are all the direction of the force due to surface tension. So on each molecule, the force due to surface tension that is acting towards downward direction. Are you clear? So these are all the forces which are acting towards downward direction. All are due to the surface tension. So these are all the forces which are acting on each molecule due to surface tension. And here the air bubble, its radius can be taken as r. Its radius can be taken as capital R. Are you clear? Now we are going to see how many number of forces are acting on the air bubble. How many number of forces which are acting on air bubble. That is our next aim. Here, look at here, one pressure is acting in the inside. Are you clear? P1 is acting inside. So one force is due to P1. One force is due to P1. Are you clear? That is acting from inside. Are you clear? That one will be equal to the sum of other two forces. What are the other forces? Another force is due to P2. Another force is due to P2, and it can be written as Fp2. That is acting towards downward direction, that is on the surface. In the same direction of P2, which one is acting? The force due to surface tension is acting. Therefore, Ft can be written. So, totally three forces are acting. One force is acting from inside, that is Fp1, and another one is FP2. What is FP2? Force due to pressure P2. That is acting on the surface, that is from outside. Ft. What is Ft? These are all the forces which are acting towards downward direction, that is due to force due to surface tension. So like this we have to write. Are you clear? So both are equal. Now the thing is, our next aim is force due to this pressure to be calculated. We know the general formula, pressure is equal to force per area. Therefore force is equal to pressure into area. Are you clear? Force is equal to pressure into, here area means which area? This lower part of the hemisphere, one cross-sectional area is there, no? That area of cross-section can be written as, since it is in the form of circle, we can write it as P into pi r square. So this is the formula from which we are able to get the expression for force due to pressure. So here force due to pressure P1 to be written. Use this formula. Instead of this, we can write, since the pressure is named as P1, P1 pi r square can be written. This is the force due to pressure P2. Therefore, P2 pi into r square can be written. Force due to surface tension. For that, we have to get the expression. In the beginning of the lesson itself, we have learnt that surface tension is equal to force per unit length. This is a fundamental formula. Surface tension expression T is equal to force per unit length. Therefore, force due to surface tension can be written as T into L. T into L can be written. Here, length. Length means the length of the rim on which the molecules are present. Each one of them, they are pulled towards downward direction due to surface tension. No, the total length of the rim to be taken, total length of the circumference to be taken. Therefore, F is equal to T into surface tension into length is nothing but circumference. What is the circumference of the circle? 2 pi r we can write. What is the formula? 2 pi r instead of L can be written. Any doubt in this? And very important thing is, in the case of air bubble, only one free surface is there. So this is the only free surface which does not have any contact with anything that is inside. So only one free surface is there. Therefore, here 1 must be written. Here number 1 can be written. If any two surfaces are there we have tried 2. Since only one free surface on which force due to surface tension is acting, therefore 1 must be written, don't forget. Now force due to surface tension formula is ready. Instead of that, T into 2 pi r can be written. Are you clear? So this is the formula. Now what we have to do, bring this factor in this side, P1 pi r square minus P2 pi r square is equal to T into 2 pi r can be written. Here P1 minus P2 can be written within the bracket. Common factor is pi r square, which is equal to T into 2 pi r can be written. Any doubt in this? Now 1 r can be cancelled, pi can be cancelled. So what is the remaining thing? This is the expression. P1 minus P2. Already I have told the difference between P1 and P2 is called excess pressure. That excess pressure will be always acting in the concave surface. So P1 minus P2, that one gives you excess pressure. Are you clear? Del P into R is equal to T into 2. So I need the expression for del P. So del P is equal to 2T by R is the expression. Are you clear? Del P is equal to 2T by R is the expression to calculate the excess pressure. This excess pressure that is always acting in this direction, that is towards the which surface? Concave surface. Are you clear? This excess pressure and force due to surface tension, both of them must be in equilibrium. That is very important. The purpose of learning excess pressure is how the bubble is in equilibrium condition. How the air bubble, it remains always in the same shape. how it is able to maintain the shape. How is it possible? As long as the excess pressure is, the force due to excess pressure is equal to force due to surface tension, the bubble will be remaining in the form of spherical shape. Are you clear? That is the purpose of learning the excess pressure. Now this is a formula to calculate the excess pressure. By knowing surface tension and radius of the air bubble, which one can be calculated? Excess pressure can be calculated. Very interesting derivation. Okay, so now we have seen air bubble. Next we are going to pass on to the liquid drop. So clear, excess pressure in the case of liquid drop, its expression to be derived. Okay, so don't forget this expression. Okay.